Question 1. Process analysis reveals that an intermittent connectivity issue is affecting a critical application hosted within a Cisco data center. Users report sporadic access failures to a web server. The network infrastructure includes Cisco Nexus switches, Cisco UCS servers, and various firewalls. The operations team needs to identify and resolve the root cause of this service degradation. Which of the following troubleshooting approaches is most aligned with best professional practices for resolving such an issue in a Cisco data center environment? Option A. Begin by examining the physical layer connectivity, including cable integrity and port status on all relevant switches and servers. Then proceed to verify data link layer configurations, such as VLAN and MAC address tables, followed by network layer checks including IP addressing and routing, and finally investigate transport and application layer issues. Option B. Focus troubleshooting efforts exclusively on the Cisco Nexus switches, assuming that the core network infrastructure is the most probable point of failure, and disregard potential issues with server hardware or other network devices until the switches are fully cleared. Option C. Immediately analyze the web server's application logs and performance metrics, assuming the issue is application-specific, and only consider network issues if application-level troubleshooting yields no results. Option D. Proactively reconfigure the firewall rules and access control lists, ACL, for the web server's IP address, hypothesizing that a recent security policy change might be the cause, without first verifying basic network reachability. Correct answer is A. Begin by examining the physical layer connectivity, including cable integrity and port status on all relevant switches and servers. Then proceed to verify data link layer configurations such as VLAN and MAC address tables, followed by network layer checks including IP addressing and routing, and finally investigate transport and application layer issues. Explanation. Scenario analysis. This scenario presents a professional challenge in a Cisco data center environment where a critical network service is experiencing intermittent failures. The challenge lies in diagnosing the root cause of the issue while minimizing service disruption and adhering to operational best practices. The intermittent nature of the problem makes it difficult to reproduce and isolate, requiring a systematic and analytical approach. Furthermore, the need to maintain service availability and potentially meet service level agreements, SLAs, adds pressure to resolve the issue efficiently and effectively. The complexity of modern data center networks, with multiple layers of technology and interconnected components, further complicates the troubleshooting process. Correct approach analysis. The correct approach involves a methodical, layered troubleshooting methodology, starting with the most fundamental aspects of the network and progressively moving to more complex ones. This aligns with industry best practices for network troubleshooting and is implicitly supported by the operational guidelines and vendor documentation, like Cisco's, that form the basis of the DCCOR certification. Specifically, beginning with physical layer checks, cabling, port status, link lights, ensures that the most basic connectivity is established. Moving to the data link layer, VLAN, MAC addresses, SDP, verifies that devices can communicate at the local network segment level. Subsequently examining the network layer, IP addressing, routing protocols, ACL, confirms end-to-end reachability. Finally, troubleshooting at the transport and application layers addresses issues related to specific services and protocols. This layered approach, often referred to as the OSI model or a similar troubleshooting framework, is crucial because it systematically eliminates potential causes, preventing wasted effort on higher-level issues when a fundamental problem exists. It is the most efficient and effective way to isolate the root cause of network problems in a complex data center environment. Incorrect approaches analysis. Focusing solely on application-level logs without verifying underlying network connectivity is a significant regulatory and ethical failure. This approach ignores the foundational principles of network operation and can lead to misdiagnosis. If the issue is a physical cable fault or a routing problem, spending time analyzing application logs is a waste of resources and delays resolution, potentially violating SLAs and customer trust. This is professionally unacceptable as it demonstrates a lack of systematic troubleshooting discipline. Immediately reconfiguring network devices without a clear understanding of the problem or its potential impact is another critical failure. This action is reckless and can exacerbate the existing issue or introduce new, more severe problems. It violates the principle of change management and can lead to widespread service outages, impacting business operations and potentially leading to financial penalties or reputational damage. This demonstrates a lack of due diligence and a disregard for operational stability. Assuming the problem is related to a specific vendor's hardware without performing comprehensive diagnostics across all network components is a premature and biased approach. This can lead to overlooking issues in other parts of the network or in the configuration of different devices. It is a failure to conduct a thorough and objective investigation, which is a cornerstone of professional network engineering. This can result in prolonged downtime and increased costs due to chasing the wrong solution. Professional reasoning. Professionals should adopt a structured, evidence-based troubleshooting methodology. This involves 1. Understanding the reported problem thoroughly. 2. Formulating hypotheses about potential causes. 3. Systematically testing these hypotheses starting with the most fundamental layers. 4. Gathering and analyzing data at each step. 5. Documenting all findings and actions taken. 6. Escalating or seeking assistance when necessary. This approach ensures that issues are resolved efficiently, minimizes service impact, and upholds professional standards of competence and responsibility. Adherence to vendor best practices and established network troubleshooting frameworks is paramount. Question 2. The audit findings indicate that network traffic between the production database VLAN and the application server VLAN is not adequately restricted, potentially exposing sensitive customer data to unauthorized access. Which of the following actions is the most appropriate and compliant response to mitigate this risk? Option A. Disable Intrusion Prevention System (IPS) signatures that are currently blocking legitimate traffic to improve the flow between the database and application servers. Option B. Remove the application server VLAN from the core network and place it in a separate, less secure DMZ segment. Option C. Implement Granular Access Control Lists (ACL) on the relevant VLAN interfaces and firewall policies to permit only necessary ports and protocols between the production database VLAN and the application server VLAN, enforcing a deny-all default. Option D. Increase the IP address range of the production database VLAN to accommodate future growth, assuming this will implicitly improve isolation. Correct answer is C. Implement Granular Access Control Lists (ACL) on the relevant VLAN interfaces and firewall policies to permit only necessary ports and protocols between the production database VLAN and the application server VLAN, enforcing a deny-all default. Explanation. The audit findings indicate a potential misconfiguration in the data center's network segmentation strategy, specifically concerning the isolation of critical application workloads. This scenario is professionally challenging because it directly impacts the security posture and operational resilience of the data center. A failure in network segmentation can lead to unauthorized access, lateral movement of threats, and service disruptions, all of which have significant business and regulatory implications. Careful judgment is required to identify the root cause and implement the most effective remediation strategy that aligns with security, best practices, and compliance requirements. The correct approach involves a thorough review of the existing access control lists, ACL, and firewall policies applied to the VLAN hosting critical applications. This includes verifying that only necessary ports and protocols are permitted between these VLAN and other network segments, and that strict deny-all policies are in place for any unexplicitly allowed traffic. This represents best professional practice because it directly addresses the identified vulnerability by enforcing the principle of least privilege at the network layer. Adhering to established security frameworks and vendor best practices for network segmentation, such as those outlined by Cisco for data center security, ensures that the implemented controls are robust and effective in preventing unauthorized access and containing potential security incidents. This proactive and detailed verification process is crucial for maintaining compliance with data protection regulations and industry standards that mandate the protection of sensitive data and critical infrastructure. An incorrect approach would be to simply increase the size of the existing subnets without re-evaluating the ACLs. This fails to address the core issue of unauthorized traffic flow and could inadvertently expand the attack surface. It represents a regulatory failure by not implementing effective controls to protect sensitive data and a breach of ethical responsibility to maintain a secure environment. Another incorrect approach would be to disable security features on the network devices to improve application performance. This is a severe regulatory and ethical failure, as it directly compromises the security of the data center, potentially exposing sensitive information and violating data privacy laws. It demonstrates a disregard for established security principles and a lack of professional judgment in prioritizing short-term performance over long-term security and compliance. Professionals should employ a structured decision-making process when faced with such audit findings. This involves 1. Understanding the scope and impact of the audit finding. 2. Gathering all relevant technical data, including network configurations, traffic logs, and security policies. 3. Consulting relevant documentation and best practices from vendors and industry bodies. 4. Evaluating potential remediation strategies based on their effectiveness, feasibility, and impact on operations and security. 5. Implementing the chosen solution with rigorous testing and validation. 6. Documenting the changes and updating relevant policies and procedures. This systematic approach ensures that decisions are informed, defensible, and aligned with professional responsibilities and regulatory obligations. Question 3. Assessment of the most effective and secure method for segmenting network traffic between multiple independent tenant workloads within a Cisco data center core network, ensuring strict isolation and preventing unauthorized intertenant communication. Option A. Utilize VLAN to segregate tenant traffic at Layer 2. Option B. Apply extensive access control lists (ACL) to filter traffic between all tenant subnets. Option C. Implement virtual routing and forwarding (VRF) instances for each tenant. Option D. Deploy a single flat network without any segmentation. The correct answer is C. Implement virtual routing and forwarding (VRF) instances for each tenant. Explanation. Scenario analysis. This scenario presents a professional challenge in a Cisco data center environment where network segmentation is critical for security and operational efficiency. The challenge lies in selecting the most appropriate and compliant method for segmenting traffic between different tenant workloads, ensuring that the chosen solution adheres to best practices for data center design and operation, and importantly, aligns with the principles of network security and isolation as implicitly expected within a regulated operational context, even without explicit mention of specific U.S. regulations. The need for robust isolation without compromising performance or manageability requires careful consideration of available technologies and their implications. Correct approach analysis. Implementing virtual routing and forwarding (VRF) instances is the best professional practice in this scenario. VRFs provide a mechanism to create multiple, independent routing tables within a single physical router. This allows for logical separation of network traffic, effectively creating distinct virtual networks. For a data center core, this is crucial for tenant isolation, security policy enforcement, and preventing broadcast domain sprawl. Each tenant can have its own VRF, ensuring that their traffic is routed only within their designated network space, preventing intertenant communication unless explicitly permitted through policy. This aligns with the principle of least privilege and defense in depth, fundamental to secure data center operations. Incorrect approaches analysis. Using VLAN alone for tenant segmentation in a core data center environment is insufficient and professionally unsound. While VLAN provide Layer 2 segmentation, they are susceptible to misconfigurations and do not offer the robust isolation of Layer 3 boundaries that VRFs provide. A broadcast storm or a misconfigured trunk port could inadvertently bridge VLAN, compromising tenant isolation. Furthermore, managing a large number of VLAN for numerous tenants can become complex and error-prone, increasing the risk of security breaches. Implementing access control lists (ACL) without a proper segmentation strategy is a reactive security measure, not a proactive segmentation solution. ACLs can filter traffic between segments, but they do not inherently create the segments themselves. Relying solely on ACLs to segment traffic between tenants would require extensive and complex rule sets, which are difficult to manage, prone to errors, and do not prevent traffic from reaching its destination if the ACL is misconfigured or bypassed. This approach lacks the foundational isolation that VRFs provide. Deploying a single, flat network without any segmentation is a severe professional and security failure. This approach exposes all workloads to each other, making the entire data center vulnerable to any compromise within a single workload. It completely negates the principles of security, isolation, and operational manageability expected in a modern data center. This would be considered a gross negligence in network design and operation. Professional reasoning. When faced with the requirement to segment traffic in a data center, professionals should first identify the required level of isolation. For tenant workloads, strong Layer 3 isolation is paramount. The decision-making process should involve evaluating technologies that provide this isolation, such as VRFs, and comparing them against less robust methods like VLAN alone or purely policy-based controls like ACLs. The principle of design for security from the ground up dictates that foundational segmentation should be implemented before relying on filtering mechanisms. Professionals must consider the scalability, manageability, and security implications of each approach, prioritizing solutions that offer the most robust and maintainable isolation. Question 4. Comparative studies suggest that in a dynamic data center environment, the speed of new service deployment is often in tension with the imperative for operational stability. A critical new application is slated for deployment, and the business unit is pushing for an immediate go-live to capture market advantage. The data center operations team has identified that a comprehensive staging and phased rollout strategy, while ensuring robustness, will add 2 weeks to the deployment timeline. What is the most professionally responsible approach to managing this deployment? Option A. Bypass all testing and validation procedures, relying solely on the vendor's assurances for the application's stability and compatibility. Option B. Implement the service with only basic functional testing in the production environment, deferring performance and security validation to a later date. Option C. Deploy the new service directly into the production environment immediately to meet the business unit's aggressive timeline. Option D. Proceed with a phased deployment, starting with a pilot group of users in a production segment, followed by incremental expansion after successful validation at each stage. Correct answer is D. Proceed with a phased deployment, starting with a pilot group of users in a production segment, followed by incremental expansion after successful validation at each stage. Explanation. Scenario analysis. This scenario presents a common challenge in data center operations, balancing the need for rapid deployment of new services with the imperative to maintain network stability and security. The pressure to deliver new applications quickly can lead to shortcuts in testing and validation, potentially introducing vulnerabilities or performance degradation. The professional challenge lies in advocating for rigorous, albeit time-consuming, processes that safeguard the integrity of the data center infrastructure against the business's demand for speed. This requires strong communication skills, a deep understanding of the technical implications of rushed deployments, and the ability to articulate risks in business-relevant terms. Correct approach analysis. The correct approach emphasizes a phased deployment strategy with comprehensive validation at each stage. This aligns with best practices for implementing new technologies in a critical infrastructure environment. By performing thorough testing in a staging environment that mirrors production, and then gradually rolling out to a subset of production users before a full deployment, the risk of widespread disruption is significantly mitigated. This methodical approach ensures that any unforeseen issues are identified and resolved in a controlled manner, minimizing impact on the broader user base and critical business operations. This aligns with the principles of operational excellence and risk management inherent in IT service delivery, which are implicitly supported by regulatory frameworks focused on service availability and data integrity. Even if not explicitly detailed in the DCCOR exam syllabus itself, the focus is on proactive risk mitigation and controlled change management. Incorrect approaches analysis. Implementing the new service directly into the production environment without prior staging or phased rollout is a direct violation of sound change management principles. This approach introduces an unacceptable level of risk, as any defect or incompatibility could immediately impact all users and critical services, leading to significant business disruption and potential data loss. This failure to implement adequate controls and testing would be considered a significant professional lapse, potentially leading to reputational damage and financial penalties if service-level agreements (SLAs) are breached. Deploying the service with only basic functional testing in production, skipping performance and security validation, is also professionally unsound. While it might seem faster, it leaves the data center vulnerable to performance bottlenecks, denial of service attacks, or exploitation of newly introduced security flaws. This demonstrates a lack of due diligence in ensuring the overall health and security posture of the data center, which is a core responsibility of data center professionals. Attempting to deploy the service without any form of validation or testing, relying solely on vendor claims, is the most reckless approach. This completely disregards the unique configuration and operational context of the specific data center, which can often lead to unexpected conflicts and failures. It represents a complete abdication of professional responsibility and a disregard for the potential consequences of a failed deployment. Professional reasoning. Professionals should adopt a risk-based decision-making framework. This involves 1. Identifying potential risks associated with any proposed change. 2. Assessing the likelihood and impact of those risks. 3. Developing mitigation strategies to reduce or eliminate unacceptable risks. 4. Communicating these risks and mitigation plans clearly to stakeholders. In the context of data center operations, this framework mandates a structured approach to change management, prioritizing stability, security, and availability. When faced with pressure to accelerate deployments, professionals must be empowered to advocate for the necessary validation steps, framing the discussion around the potential business impact of failure rather than just technical timelines. Question 5. Cost-benefit analysis shows that implementing a new software-defined networking (SDN) overlay solution will significantly improve application performance and network agility within the data center. However, the proposed SDN overlay utilizes a proprietary control plane protocol that has not been widely vetted for security vulnerabilities by independent bodies, and its integration with existing security monitoring tools is not fully documented. The IT security team has raised concerns about potential blind spots and the difficulty of auditing traffic flows within the overlay. Which of the following approaches best balances the performance benefits with the security and operational integrity of the data center? Option A. Reject the SDN overlay solution outright due to the unvetted nature of its control plane protocol and the potential security risks, opting to maintain the current network infrastructure despite its performance limitations. Option B. Implement the SDN overlay in a limited production segment, relying solely on the vendor's documentation for security configuration, and assuming that any security issues will be minor and easily resolved by the vendor's support team. Option C. Proceed with the full production deployment of the SDN overlay immediately to capitalize on the performance gains, assuming the vendor's security assurances are sufficient and addressing any security concerns post-implementation. Option D. Conduct a comprehensive proof of concept, POC, in a dedicated lab environment that mirrors the production network, focusing on security testing, integration with existing security tools, and traffic flow analysis before considering a phased production rollout. The correct answer is C. Proceed with the full production deployment of the SDN overlay immediately to capitalize on the performance gains, assuming the vendor's security assurances are sufficient and addressing any security concerns post-implementation. Explanation. This scenario presents a common challenge in data center operations, balancing the immediate need for enhanced network performance with the long-term implications of technology choices, particularly concerning security and compliance. The professional challenge lies in evaluating a proposed solution that offers significant performance gains, but introduces a new, potentially less understood security paradigm. Careful judgment is required to ensure that the pursuit of efficiency does not compromise the integrity and security of the data center, which is paramount in a regulated environment. The correct approach represents best professional practice because it prioritizes a thorough risk assessment and validation process before full implementation. This aligns with the principles of responsible technology adoption, ensuring that any new solution is not only technically sound, but also meets stringent security and compliance requirements. In the context of the 350-601 DCCOR exam, this translates to understanding the operational and security implications of advanced networking technologies and implementing them in a controlled, verifiable manner. The emphasis on testing in a lab environment and seeking expert validation before production deployment is a cornerstone of robust IT governance and risk management. An incorrect approach that focuses solely on the performance benefits without adequate security vetting would represent a significant regulatory and ethical failure. This could lead to vulnerabilities that expose sensitive data, violating data protection regulations. For instance, Deploying a technology without understanding its security implications could inadvertently create backdoors or introduce unpatched vulnerabilities, directly contravening the principle of maintaining a secure and resilient infrastructure. Another incorrect approach, such as relying on vendor claims without independent verification, demonstrates a lack of due diligence. This can lead to the adoption of technologies that do not meet the organization's specific security posture or regulatory obligations, potentially resulting in non-compliance and significant financial or reputational damage. The professional reasoning process for similar situations should involve a structured approach. 1. Identify the business need and propose solution. 2. Conduct a comprehensive risk assessment, including security, operational, and compliance risks. 3. Evaluate the proposed solution against existing security policies and regulatory requirements. 4. Perform thorough testing in a non-production environment. 5. Seek expert consultation and validation. 6. Develop a phased deployment plan with rollback capabilities. 7. Establish ongoing monitoring and management procedures. This systematic process ensures that technology decisions are informed, secure, and compliant. Question 6. To address the challenge of integrating a new virtualized network service into an existing Cisco data center environment, which approach best balances rapid deployment with the imperative of maintaining network stability and operational integrity? Option A. Integrate the service using a Big Bang approach, deploying it across the entire data center simultaneously to minimize the duration of any potential disruption. Option B. Deploy the service in a limited production segment without extensive testing, relying on the vendor's reputation for stability and assuming minimal impact. Option C. Conduct a comprehensive proof of concept in a lab environment, followed by a staged rollout to production with rigorous monitoring and rollback capabilities. Option D. Implement the new service directly into the production environment after a brief review of vendor documentation, prioritizing immediate availability to meet business demands. Correct answer is D. Implement the new service directly into the production environment after a brief review of vendor documentation, prioritizing immediate availability to meet business demands. Explanation. The scenario presents a common challenge in data center operations, balancing the need for rapid deployment of new services with the imperative to maintain network stability and security, all within the context of evolving regulatory compliance. The professional challenge lies in making informed decisions that prioritize both business agility and adherence to established operational best practices and potential regulatory mandates, without compromising the integrity of the data center infrastructure. Careful judgment is required to assess the risks associated with different implementation strategies. The correct approach represents best professional practice because it emphasizes a phased, controlled, and validated deployment methodology. This aligns with industry standards for network engineering and data center operations, which prioritize minimizing disruption and ensuring service availability. By incorporating thorough testing, staged rollouts, and robust monitoring, this approach proactively identifies and mitigates potential issues before they impact production environments. This methodical process is crucial for maintaining a stable and secure data center, which indirectly supports compliance with operational integrity requirements often found in data protection and service level agreements, even if specific regulations are not explicitly detailed in the exam syllabus. Incorrect approaches fail to meet professional standards due to inherent risks and a disregard for systematic operational procedures. One incorrect approach, which bypasses standard change control and testing, introduces significant risk of service disruption and security vulnerabilities. This directly contravenes the principle of responsible network management and could lead to non-compliance with internal policies and potentially external service level agreements or data handling regulations if service outages or data breaches occur. Another incorrect approach, which relies solely on vendor documentation without internal validation, overlooks the unique configuration and operational context of the specific data center. This can lead to unforeseen compatibility issues or security gaps, again risking operational stability and compliance. A third incorrect approach, which prioritizes speed over thoroughness without a clear risk assessment, demonstrates a lack of due diligence. This can result in rushed implementations that overlook critical security configurations or performance tuning, ultimately increasing the likelihood of future problems and potential compliance failures. A professional decision-making process for similar situations should involve a structured risk assessment framework, Before implementing any new technology or significant change, professionals should 1. Clearly define the business objective and technical requirements. 2. Identify potential risks to stability, security, and performance. 3. Evaluate different implementation strategies against these risks, considering factors like testing, rollback procedures, and monitoring. 4. Select the approach that offers the best balance between achieving the objective and mitigating risks, adhering to established operational procedures and best practices. 5. Document the decision-making process and the chosen implementation plan. Question 7. The audit findings indicate that network segmentation within the data center is not consistently enforced, leading to a broader attack surface than intended. Specifically, the auditor noted that traffic between different application tiers is not adequately restricted, potentially allowing lateral movement of threats. Based on the principles covered in the 350-601 Implementing and Operating Cisco Data Center Core Technologies exam, which of the following actions is the most appropriate response to address this audit finding? Option A. Deploy a new intrusion prevention system, IPS, at the data center perimeter to detect and block malicious traffic entering the network, without altering the internal segmentation. Option B. Rely on endpoint security solutions on individual servers to mitigate the risk of lateral movement, as network segmentation is overly complex to implement effectively. Option C. Increase the overall bandwidth of the data center network to improve performance, assuming that the current segmentation issues are a symptom of network congestion. Option D. Implement granular access control lists, ACL, on all interVLAN routing interfaces and within virtual routing and forwarding, VRF, instances to restrict traffic flow based on application requirements and security policies. Correct answer is D. Implement granular access control lists, ACL, on all interVLAN routing interfaces and within virtual routing and forwarding, VRF, instances to restrict traffic flow based on application requirements and security policies. Explanation. The audit findings highlight a critical gap in the organization's data center security posture, specifically concerning the implementation and operationalization of network segmentation. This scenario is professionally challenging because it requires a deep understanding of network security principles, Cisco's data center technologies, and the implications of inadequate segmentation on compliance and risk management. The auditor's observation implies a potential violation of security best practices and possibly regulatory requirements related to data protection and system integrity. The correct approach involves a comprehensive review and remediation of the network segmentation strategy, aligning it with industry best practices and relevant Cisco DCCOR curriculum objectives. This includes verifying the correct implementation of access control lists, ACL, virtual routing and forwarding, VRF, instances, and potentially microsegmentation technologies like Cisco ACI. This approach represents best professional practice because it directly addresses the identified vulnerability, minimizes the attack surface, and ensures that sensitive data and critical systems are adequately protected from unauthorized access. Adhering to these principles is crucial for maintaining operational resilience and meeting potential compliance mandates that require robust security controls. An incorrect approach would be to dismiss the audit finding as a minor issue or to implement superficial changes without a thorough understanding of the underlying network architecture and security implications. For instance, simply updating firewall rules without re-evaluating the segmentation strategy itself could leave critical vulnerabilities unaddressed. Another incorrect approach would be to focus solely on perimeter security, neglecting the internal segmentation that is vital for containing breaches. These approaches fail to address the root cause of the security gap and could lead to continued noncompliance and increased risk. Ethically, failing to adequately secure the data center infrastructure, especially after an audit finding, constitutes a dereliction of professional duty to protect organizational assets and sensitive information. Professionals should approach such situations by first thoroughly understanding the audit findings and their potential impact. This involves consulting relevant documentation, engaging with the network engineering and security teams, and referencing the Cisco DCCOR curriculum for best practices in data center network design and security. A systematic approach to remediation, including design review, implementation verification, and ongoing monitoring, is essential. Prioritization should be based on the criticality of the systems and data affected by the segmentation gaps. Question 8. System analysis indicates a critical network service within a Cisco data center environment requires an urgent firmware update to address a newly discovered security vulnerability. The update is known to have a high success rate, but has not been tested in the organization's specific production configuration. The IT operations team is under pressure to deploy the update immediately to mitigate the risk of exploitation, which approach best balances the need for immediate security remediation with the imperative to maintain service stability and operational integrity. Option A. Update only a portion of the production servers with the new firmware to assess its impact before proceeding with the rest of the environment. Option B. Deploy the firmware update directly to the production environment during a scheduled maintenance window, with a plan to roll back if significant issues arise. Option C. Implement the firmware update in a dedicated lab environment that mirrors the production configuration, thoroughly test all service functionalities, and then schedule a phased rollout to the production environment during off-peak hours. Option D. Proceed with the firmware update on all production servers immediately, prioritizing the security fix over potential temporary service disruptions. The correct answer is B. Deploy the firmware update directly to the production environment during a scheduled maintenance window, with a plan to roll back if significant issues arise. Explanation: Scenario analysis. This scenario presents a common challenge in data center operations where a critical network service needs to be updated. A professional challenge lies in balancing the imperative to maintain service availability and performance with the necessity of implementing necessary upgrades to ensure security and compliance. The pressure to minimize downtime, coupled with potential business impact, requires a meticulous and risk-aware approach. Understanding the underlying technologies and their interdependencies is crucial for making informed decisions that safeguard the integrity of the data center infrastructure. Correct approach analysis. The correct approach involves a phased rollout of the network service update, starting with a controlled test environment. This aligns with best practices for change management and risk mitigation, which are implicitly supported by operational guidelines and vendor best practices for Cisco technologies. By validating the update in a non-production setting, potential issues can be identified and resolved before impacting live services. This proactive stance minimizes the risk of service disruption, data loss, or security vulnerabilities, thereby upholding operational stability and user trust. This methodology is a cornerstone of robust IT service management, ensuring that changes are implemented predictably and with minimal adverse effects. Incorrect approaches analysis. Implementing the update directly on the production environment without prior testing is a significant regulatory and ethical failure. It demonstrates a disregard for operational stability and risk management, potentially violating service-level agreements, SLAs, and exposing the organization to financial and reputational damage. Such an approach could be seen as negligent, as it bypasses established procedures designed to protect critical infrastructure. Performing the update during peak business hours without adequate rollback planning is another failure. This directly contradicts the principle of minimizing business impact and demonstrates a lack of foresight. It increases the likelihood of service disruption during periods of high demand, leading to customer dissatisfaction and potential revenue loss. Furthermore, the absence of a rollback plan signifies an inability to recover gracefully from unforeseen issues, which is a fundamental aspect of responsible IT operations. Updating only a subset of the production environment without a clear strategy for the remaining systems is also professionally unacceptable. This creates an inconsistent and potentially unstable environment. It introduces complexity in management and troubleshooting, and it does not guarantee that the entire service is operating under the intended updated configuration. This approach lacks the systematic rigor required for critical infrastructure changes and could lead to unpredictable behavior and security gaps. Professional reasoning. Professionals should adopt a structured change management process. This involves thorough planning, risk assessment, testing in a lab or staging environment, phased deployment, comprehensive monitoring, and a well-defined rollback strategy. Decision-making should prioritize service continuity, security, and compliance, always considering the potential impact on business operations. When faced with critical updates, the default should be a cautious, iterative approach that allows for validation and correction at each stage. Question 9. The assessment process reveals that a critical new application deployment is falling behind schedule due to extensive manual validation steps. The project manager is pushing for a streamlined approach to accelerate the rollout, suggesting the elimination of certain automated testing phases and a direct deployment to the production environment. Which of the following approaches best balances the need for rapid deployment with the operational integrity and stability of the data center? Option A. Implement a phased rollout strategy with automated pre-deployment checks and a rollback plan, while documenting all changes and conducting a post-deployment review. Option B. Eliminate all automated testing and deploy the application directly to the production environment to meet the aggressive deadline. Option C. Reduce the scope of testing to only the most critical functionalities, bypassing comprehensive validation of peripheral services. Option D. Prioritize speed by manually configuring network devices and skipping detailed documentation, focusing only on getting the application live. Correct answer is A. Implement a phased rollout strategy with automated pre-deployment checks and a rollback plan, while documenting all changes and conducting a post-deployment review. Explanation: the assessment process reveals a common challenge in data center operations, balancing the need for rapid deployment of new services with the imperative to maintain operational stability and compliance. In the context of the 350-601 DCCOR exam, this scenario is professionally challenging because it requires a deep understanding of how process optimization directly impacts the reliability, security, and efficiency of a data center environment, all of which are subject to stringent operational guidelines and best practices. The pressure to deliver quickly can lead to shortcuts that compromise these critical aspects. The correct approach, focusing on iterative refinement of deployment workflows through automated testing and phased rollouts, represents best professional practice because it aligns with the principles of continuous improvement and risk mitigation. This methodology ensures that new configurations or services are validated in a controlled manner, minimizing the potential for widespread disruption. It also supports adherence to operational standards by building in checkpoints for verification and rollback, which are implicitly or explicitly required by operational frameworks that emphasize stability and fault tolerance. An incorrect approach that bypasses automated testing and deploys changes directly to production environments without staged validation is professionally unacceptable. This failure constitutes a significant ethical and operational risk. It violates the implicit professional duty to safeguard the integrity and availability of the data center infrastructure. Such an approach increases the likelihood of introducing errors that could lead to service outages, data corruption, or security vulnerabilities, all of which can have severe business and reputational consequences. Another incorrect approach that involves manual configuration of critical network devices for new deployments, even if seemingly faster, is also professionally unsound. This introduces a high degree of human error, which is a primary cause of data center incidents. It deviates from best practices that advocate for automation to ensure consistency and repeatability, thereby reducing the risk of misconfiguration. This failure to leverage automation for critical tasks undermines the efficiency and reliability goals of modern data center operations. A third incorrect approach that prioritizes speed over comprehensive documentation and post-deployment review is equally problematic. While rapid deployment is desirable, neglecting proper documentation and review processes creates a knowledge gap. This makes troubleshooting future issues more difficult and hinders the ability to learn from the deployment, thereby impeding long-term process optimization. It also makes it harder to demonstrate compliance with operational procedures and audit requirements. A professional decision-making process for similar situations should involve a risk-based assessment of proposed changes. This includes evaluating the potential impact of a change on service availability, security, and performance. Professionals should advocate for methodologies that incorporate automated validation, phased deployments, and thorough documentation. When faced with pressure to expedite processes, it is crucial to articulate the risks associated with shortcuts and to propose alternative, compliant, and robust solutions that balance speed with stability and security. Question 10. Consider a scenario where a financial services organization is implementing network segmentation within its data center to enhance security and meet compliance requirements. The goal is to isolate critical financial transaction systems from less sensitive development environments. The IT team is evaluating different strategies for deploying access control lists, ACL, and firewall rules to enforce this segmentation. Which approach best balances security, operational stability, and compliance? Option A. Develop and test ACLs and firewall rules in a dedicated lab environment that mirrors the production network, followed by a phased rollout to production with rigorous monitoring. Option B. Apply a broad, restrictive set of ACLs and firewall rules to all network segments initially, then gradually loosen restrictions based on user feedback and reported issues. Option C. Utilize a generic set of ACLs and firewall rules that are commonly used for data center segmentation, without specific analysis of the financial transaction system's dependencies and traffic patterns. Option D. Implement ACLs and firewall rules in a production environment during peak business hours, relying on immediate rollback if issues arise. The correct answer is D. Implement ACLs and firewall rules in a production environment during peak business hours, relying on immediate rollback if issues arise. Explanation. This scenario presents a professional challenge due to the critical nature of data center operations and the potential impact of network segmentation failures on business continuity and data security. The need to implement robust segmentation without disrupting existing services requires a thorough understanding of network architecture, security policies, and the specific technologies involved. Careful judgment is essential to balance security requirements with operational stability. The correct approach represents best professional practice because it prioritizes a phased, controlled implementation of network segmentation. This aligns with industry best practices for network changes, emphasizing minimal disruption and thorough validation. Specifically, it adheres to the principles of change management and risk mitigation, ensuring that security policies are effectively applied without introducing unintended outages or vulnerabilities. This methodical approach is implicitly supported by general IT governance frameworks that advocate for structured deployments and testing. An incorrect approach that bypasses thorough testing and validation before full deployment poses significant regulatory and ethical risks. It could lead to data breaches if segmentation controls are misconfigured, violating data protection regulations. Furthermore, it demonstrates a failure to exercise due diligence and professional responsibility, potentially resulting in service disruptions that impact customers or internal operations, which could have financial and reputational consequences. Another incorrect approach, focusing solely on implementing the most restrictive segmentation without considering application dependencies, is also professionally unsound. This can lead to legitimate traffic being blocked, causing service outages and impacting business operations. Ethically, it fails to consider the operational impact and the principle of least disruption. A third incorrect approach, relying on outdated or generic security policies that do not account for the specific requirements of the data center environment, is professionally negligent. This can result in ineffective segmentation, leaving critical assets vulnerable to threats. It also fails to meet the evolving security landscape and the specific compliance needs of the organization. The professional decision-making process for similar situations should involve a structured risk assessment, a detailed implementation plan with rollback procedures, thorough testing in a lab environment, and a phased rollout with continuous monitoring. Professionals must prioritize understanding the business impact of any proposed change and ensure that security measures are implemented in a way that supports, rather than hinders, operational objectives. Adherence to established change management processes and a commitment to continuous validation are paramount. Question 11. The investigation demonstrates that a network engineer is responsible for deploying a new VXLAN FBIN fabric in a Cisco data center environment. The engineer has a tight deadline and is considering several implementation strategies. Which strategy best balances rapid deployment with operational stability and risk mitigation? Option A. Deploy the VXLAN FBIN fabric based on initial design documents without consulting application owners or performing pre-deployment validation of dependencies. Option B. Prioritize completing the physical cabling and initial device configurations rapidly, deferring comprehensive testing and documentation until after the fabric is declared operational. Option C. Deploy the VXLAN FBIN fabric in a phased approach, with each phase involving configuration, connectivity testing, and validation of tenant services before proceeding to the next. Option D. Implement the entire VXLAN FBIN fabric in a single, large-scale deployment, prioritizing speed to meet the deadline. The correct answer is D. Implement the entire VXLAN FBAN fabric in a single, large-scale deployment, prioritizing speed to meet the deadline. Explanation. The investigation demonstrates a scenario where a network engineer is tasked with implementing a new data center network fabric using VXLAN. This is professionally challenging because the successful implementation and operation of such a complex technology directly impact business continuity, application performance, and security. Misconfigurations or a lack of understanding of the underlying protocols can lead to widespread outages, data breaches, and significant financial losses. Furthermore, the engineer must ensure that the chosen implementation adheres to Cisco's best practices and the specific requirements of the organization, which often involves balancing cutting-edge technology with operational stability and maintainability. The correct approach, focusing on a phased rollout with thorough validation at each stage, represents best professional practice because it minimizes risk. This methodology aligns with industry standards for complex network deployments, emphasizing a structured and controlled implementation. By segmenting the deployment into manageable phases e.g., control plane setup, initial leaf-spine connectivity, tenant VRF deployment, service insertion, the engineer can isolate and troubleshoot issues more effectively. Each phase includes rigorous testing, verification of reachability, policy enforcement, and performance monitoring. This iterative validation process ensures that the fabric is stable and functional before proceeding to the next stage, thereby preventing cascading failures and ensuring a robust and reliable data center infrastructure. This approach is implicitly supported by Cisco's own recommended deployment guides and operational best practices for data center technologies, which prioritize stability and predictability. An incorrect approach that involves a big bang deployment without intermediate validation is professionally unacceptable. This method introduces a high degree of risk, as any single misconfiguration can bring down the entire fabric. It violates the principle of least privilege and controlled change, making troubleshooting exponentially more difficult and time-consuming. The regulatory and ethical failure here lies in the disregard for operational integrity and the potential for significant business disruption, which could have severe financial and reputational consequences for the organization. Another incorrect approach, deploying the fabric without consulting existing network documentation or engaging with application owners, is also professionally flawed. This demonstrates a lack of due diligence and collaboration. The failure is ethical because it neglects the interconnectedness of the data center infrastructure with business applications and services. Without understanding application requirements, e.g., specific traffic patterns, latency sensitivities, security policies, the implemented fabric might not meet operational needs, leading to performance degradation or security vulnerabilities. This can indirectly lead to non-compliance with service-level agreements, SLAs, and potentially regulatory requirements related to data availability and integrity. A third incorrect approach, prioritizing speed of deployment over thorough testing and documentation, is a critical professional and ethical lapse. While time to market is important, it should never come at the expense of a stable and secure infrastructure. The failure is ethical because it prioritizes expediency over responsibility, potentially creating long-term operational debt and security risks. Inadequate documentation makes future troubleshooting, maintenance, and upgrades significantly more challenging, increasing the likelihood of errors and outages. This can also hinder compliance audits and incident response efforts. The professional reasoning process for such a situation should involve a risk-based approach. Before any implementation, a thorough understanding of the project's scope, objectives, and potential impacts is crucial. This includes identifying all stakeholders, understanding application dependencies, and assessing potential risks. A phased implementation plan with clearly defined milestones and validation criteria should be developed. Each phase must include comprehensive testing, configuration verification, and performance monitoring. Documentation should be created and updated concurrently with the implementation. Finally, a rollback plan should be in place for each phase in case of unforeseen issues. This structured, risk-aware, and collaborative approach ensures that the implementation is not only technically sound, but also aligns with business objectives and operational best practices. Question 12. Upon reviewing the technical specifications for a new network virtualization solution intended for deployment within a highly regulated financial data center environment, Which of the following implementation strategies best aligns with the stringent requirements for data security, auditability, and compliance mandated by U.S. financial regulations? Option A. Implementing the virtualization solution with granular microsegmentation policies enforced at the virtual network interface level, ensuring comprehensive logging of all traffic flows and configuration changes. Option B. Integrating the virtualization solution with a limited set of security tools, prioritizing those that are easiest to deploy and manage, and deferring the implementation of advanced auditing features to a later phase. Option C. Selecting a virtualization technology that offers the most cost-effective licensing model, with plans to address security and compliance concerns through post-implementation remediation efforts. Option D. Deploying the virtualization solution with a focus on maximizing network performance and agility, relying on existing perimeter security controls to protect the virtualized environment. The correct answer is D. Deploying the virtualization solution with a focus on maximizing network performance and agility, relying on existing perimeter security controls to protect the virtualized environment. Explanation. Scenario analysis. This scenario presents a common challenge in data center operations, where the implementation of new network virtualization technologies must be balanced against existing security policies and compliance requirements. The professional is tasked with deploying a solution that offers flexibility and scalability, but must also ensure it adheres to the stringent security and operational standards mandated by the organization and relevant regulatory bodies. The challenge lies in selecting a virtualization approach that not only meets technical objectives, but also satisfies these critical governance and compliance mandates, which often involve detailed auditing and reporting capabilities. Correct approach analysis. The correct approach involves selecting a network virtualization solution that inherently supports granular segmentation and policy enforcement at the virtual network level. This aligns with best practices for data center security and compliance, as it allows for the isolation of sensitive workloads and the application of specific security controls based on their function and data sensitivity. Such solutions typically provide robust logging and auditing capabilities, which are essential for demonstrating compliance with regulatory frameworks that require traceability of network access and configuration changes. This proactive approach minimizes the risk of security breaches and simplifies compliance audits by embedding security and governance into the fabric of the virtual network. Incorrect approach is analysis. Implementing network virtualization without a clear strategy for policy enforcement and segmentation introduces significant security and compliance risks. Relying solely on physical network security controls for virtualized environments is insufficient, as it fails to address the dynamic nature of virtual machines and their interconnections. This approach creates blind spots, making it difficult to monitor traffic between virtual machines and enforce granular access policies, which is a direct violation of principles for secure data center operations and often contravenes regulatory requirements for data protection and access control. Deploying a solution that lacks comprehensive logging and auditing capabilities is a critical failure. Many regulatory frameworks, such as those governing financial services or healthcare data, mandate detailed audit trails for all network activity and configuration changes. Without these logs, it becomes impossible to investigate security incidents, demonstrate compliance, or respond effectively to audit requests, leading to potential fines and reputational damage. Choosing a virtualization technology that is not compatible with existing security orchestration and automation platforms can lead to operational inefficiencies and security gaps. If the new technology cannot integrate with established security workflows, manual intervention will be required, increasing the likelihood of human error and delaying the application of security policies. This lack of integration hinders the ability to maintain a consistent security posture across the data center, which is a fundamental requirement for compliance. Professional reasoning. Professionals in data center operations must adopt a risk-based approach to technology implementation. This involves thoroughly evaluating new solutions against established security policies, compliance requirements, and operational best practices. A key step is to conduct a comprehensive risk assessment that identifies potential vulnerabilities and compliance gaps associated with the proposed technology. When selecting network virtualization solutions, priority should be given to those that offer built-in security features, granular control, and robust auditing capabilities. Furthermore, ensuring compatibility with existing security and management tools is crucial for maintaining a unified and effective security posture. Professionals should always consult relevant organizational policies and industry-specific regulatory guidelines to ensure full adherence. Question 13. To address the challenge of rapidly deploying new data center services while ensuring adherence to security and compliance mandates, what is the most effective stakeholder-aligned approach for integrating security and compliance validation into the technology lifecycle? Option A. Rely solely on the business unit's self-assessment of security and compliance requirements without independent verification. Option B. Establish a mandatory, documented security and compliance review process that is integrated into the defined stages of the service deployment lifecycle, with clear responsibilities for all involved stakeholders. Option C. Implement security and compliance checks only reactively in response to specific incidents or audit findings. Option D. Defer all security and compliance validation to the post-deployment phase to avoid delaying the initial service launch. Correct answer is B. Establish a mandatory, documented security and compliance review process that is integrated into the defined stages of the service deployment lifecycle, with clear responsibilities for all involved stakeholders. Explanation. Scenario analysis. The scenario presents a common challenge in data center operations, balancing the need for rapid deployment of new services with the imperative to maintain robust security and compliance. Stakeholders, particularly business units, often prioritize speed to market, which can lead to pressure to bypass or expedite security reviews. This creates a tension between operational agility and risk management, requiring careful judgment to ensure that technological advancements do not compromise the organization's security posture or regulatory standing. The complexity arises from the interconnectedness of data center infrastructure, the sensitive nature of the data it handles, and the evolving threat landscape. Correct approach analysis. The correct approach involves a proactive and integrated security and compliance framework that is embedded within the technology lifecycle. This means establishing clear, documented processes for security reviews and compliance checks that are mandatory at defined stages of deployment. It emphasizes collaboration between IT operations, security teams, and business stakeholders to ensure that security and compliance requirements are understood and addressed early in the planning phase, rather than being an afterthought. This approach aligns with best practices for data center security and operational resilience, which are often implicitly or explicitly mandated by industry standards and regulatory expectations for data protection and operational integrity. By integrating these checks, the organization mitigates risks of breaches, non-compliance, and service disruptions, thereby protecting its reputation and financial stability. Incorrect approach is analysis. One incorrect approach is to defer security and compliance validation until after the service has been deployed and is in production. This represents a significant regulatory and ethical failure. From a regulatory standpoint, many frameworks e.g., GDPR, HIPAA, PCI DSS, depending on the jurisdiction and data handled, require security controls to be in place before data is processed or services are made available. Deploying without prior validation can lead to immediate noncompliance, resulting in substantial fines, legal liabilities, and reputational damage. Ethically, it demonstrates a disregard for data privacy and security, potentially exposing customers and the organization to harm. Another incorrect approach is to rely solely on the business unit's self-assessment of security and compliance needs, without independent verification by dedicated security and compliance teams. This is professionally unacceptable because it introduces a conflict of interest and lacks the necessary expertise and objectivity. Business units may not possess the specialized knowledge to identify all potential security vulnerabilities or understand the nuances of relevant regulations. This can lead to overlooked risks and a false sense of security, creating a significant compliance gap and exposing the organization to regulatory penalties and security incidents. A third incorrect approach is to implement security and compliance checks only when a specific incident or audit has occurred. This reactive stance is a clear failure of due diligence and risk management. It implies that security and compliance are not ongoing operational concerns, but rather responses to crises. This approach is fundamentally at odds with proactive security postures and regulatory requirements that mandate continuous monitoring and adherence to standards. It significantly increases the likelihood of undetected vulnerabilities and ongoing noncompliance, leading to severe consequences when discovered. Professional reasoning. Professionals should adopt a risk-based, proactive approach to data center operations. This involves establishing a clear governance framework that defines roles, responsibilities, and processes for security and compliance. Key decision-making steps include: 1. Understanding the regulatory landscape relevant to the data center's operations and the data it handles. 2. Implementing a robust change management process that mandates security and compliance reviews at critical junctures of any deployment or modification. 3. Fostering strong communication and collaboration between IT operations, security, compliance, and business stakeholders to ensure shared understanding of requirements and risks. 4. Leveraging automation and tooling to streamline security and compliance checks where possible without compromising thoroughness. 5. Conducting regular audits and assessments to ensure ongoing adherence to policies and regulations. This systematic approach ensures that security and compliance are integral to the operational lifecycle, rather than being add-ons, thereby safeguarding the organization and its stakeholders. Question 14. Examination of the data shows a critical core switch in the data center has experienced a complete failure, resulting in a significant network outage affecting multiple services. Initial diagnostics indicate a hardware fault, but the exact component is not immediately identifiable. The pressure to restore services is immense, and the team is considering several immediate actions. Which of the following actions represents the most professional and effective approach to resolving this critical incident? Option A. Apply a configuration change that was successful in resolving a similar, but unrelated, past network issue to the failed switch. Option B. Immediately replace the entire core switch with a pre-configured spare unit to expedite service restoration. Option C. Roll back the switch's configuration to the last known stable state before the failure occurred, assuming the fault is configuration-related. Option D. Attempt to isolate the faulty hardware component within the existing switch and replace only that specific component, documenting the process meticulously. The correct answer is B. Immediately replace the entire core switch with a pre-configured spare unit to expedite service restoration. Explanation. Scenario analysis. This scenario presents a common challenge in data center operations, a critical network device failure impacting service availability. The professional challenge lies in balancing the immediate need to restore service with the requirement to adhere to established operational procedures and change management protocols. Rushing a fix without proper validation or documentation can lead to further instability, security vulnerabilities, or noncompliance with internal policies and potentially external regulatory requirements if the data center handles sensitive information. The pressure to resolve the outage quickly can tempt engineers to bypass standard procedures, making sound judgment and adherence to best practices paramount. Correct approach analysis. The correct approach involves a systematic troubleshooting process that prioritizes data integrity and operational stability. This includes isolating the fault, performing a root cause analysis, and implementing a validated solution. Documenting the incident, the troubleshooting steps, and the resolution is crucial for post-incident review, knowledge sharing, and compliance. This methodical approach ensures that the fix is not only effective, but also sustainable and auditable, aligning with best practices for IT service management and operational resilience. It minimizes the risk of introducing new issues and provides a clear record of actions taken, which is vital for accountability and future problem-solving. Incorrect approaches analysis. Implementing a fix without a clear understanding of the root cause is a significant ethical and professional failure. It risks a temporary resolution that doesn't address the underlying problem, leading to recurring outages and potential data corruption. This bypasses the due diligence expected of a data center professional and can violate internal service level agreements, SLAs, and operational standards. Applying a configuration change from a previous, unrelated incident without verifying its applicability to the current situation is also professionally unacceptable. This demonstrates a lack of critical thinking and a reliance on assumptions, which can have severe consequences, including service disruption or security breaches. It fails to account for the unique context of the current failure and ignores the principle of verifying solutions before deployment. Restoring the device to a previous known good state without first attempting to diagnose the specific failure point is inefficient and potentially disruptive. While rollback is a valid recovery strategy, it should be a considered step after initial troubleshooting, not the first resort. This approach can mask underlying issues that might re-emerge and does not contribute to understanding the failure, hindering long-term system improvement. It also risks losing valuable diagnostic data that could have informed a more precise fix. Professional reasoning. Professionals should approach such incidents by following a structured incident response plan. This typically involves 1. Identification and logging. Clearly define the problem and its impact. 2. Triage and prioritization. Assess the severity and urgency. 3. Diagnosis. Gather data and perform root cause analysis. 4. Resolution and recovery. Implement a validated solution. 5. Closure and review. Document the incident, resolution, and lessons learned. Adherence to change management processes, even under pressure, is critical for maintaining a stable and secure environment. Question 15. The performance metrics show a consistent increase in packet drops on several Nexus switches within the data center fabric, coinciding with a recent increase in east-west traffic. The network team suspects a congestion issue, but the exact source and the most effective remediation strategy are unclear. Option A. Immediately upgrade the firmware on all affected Nexus switches to the latest stable version, assuming a potential bug in the current firmware is causing the packet drops. Option B. Analyze traffic patterns using NetFlow or span sessions to identify the specific applications or hosts generating the highest volume of east-west traffic, and then implement CO-S policies to prioritize critical traffic and potentially rate limit non-essential traffic on the affected interfaces. Option C. Revert the recent application deployment that coincided with the traffic increase, without confirming if it is the direct cause of the packet drops. Option D. Increase the buffer sizes on the affected Nexus switch interfaces, without further investigation into the traffic patterns or the root cause of the congestion. The correct answer is B. Analyze traffic patterns using NetFlow or span sessions to identify the specific applications or hosts generating the highest volume of east-west traffic, and then implement CO-S policies to prioritize critical traffic and potentially rate limit non-essential traffic on the affected interfaces. Explanation. This scenario presents a common challenge in data center operations, balancing performance optimization with resource allocation and potential security implications. The professional challenge lies in interpreting performance metrics accurately, understanding the underlying causes of anomalies, and implementing solutions that are effective, efficient, and compliant with operational policies and security best practices. A hasty or misinformed decision can lead to degraded performance, increased costs, or even security vulnerabilities. The correct approach involves a systematic investigation that begins with understanding the observed performance deviations. This includes correlating the metrics with recent changes in the environment, such as application deployments, configuration updates, or traffic patterns. Identifying the root cause is paramount before implementing any remediation. In a Cisco data center context, this often involves leveraging Cisco's integrated tools and understanding how various components, e.g., Nexus switches, UCS servers, ASI, interact. The correct approach emphasizes a data-driven, methodical troubleshooting process, prioritizing solutions that address the identified root cause without introducing new risks. This aligns with professional best practices for network and data center management, which mandate thorough analysis and risk assessment before making changes. An incorrect approach would be to immediately assume a specific component is at fault without sufficient evidence. For example, solely focusing on CPU utilization on a server without considering network latency or storage I/O as contributing factors would be a flawed strategy. Another incorrect approach would be to implement a broad, unverified configuration change across multiple devices in an attempt to fix the issue, which could have unintended consequences and violate change management protocols. A third incorrect approach would be to ignore the performance anomaly, hoping it resolves itself, which is unprofessional and can lead to more significant problems down the line. These incorrect approaches fail to adhere to the principles of systematic troubleshooting, risk management, and adherence to operational procedures, which are critical for maintaining a stable and secure data center environment. The professional decision-making process for similar situations should involve 1. Define the problem clearly based on observed data. 2. Gather all relevant contextual information, recent changes, traffic patterns, system logs. 3. Formulate hypotheses about potential root causes. 4. Test hypotheses systematically starting with the most probable. 5. Implement the most effective and least disruptive solution based on confirmed root cause. 6. Monitor the impact of the solution and adjust as necessary. 7. Document the entire process and resolution. Question 16. Compliance review shows that a critical business initiative requires the immediate implementation of network segmentation using VXLAN to isolate sensitive workloads. The project team is under significant pressure to deploy this solution within the next 48 hours, and there are concerns that a full validation cycle might delay the launch. What is the most appropriate approach to ensure both timely deployment and operational integrity? Option A. Implement VXLAN in a phased approach, starting with a small non-critical segment, and conduct thorough validation of control plane and data plane configurations at each stage, integrated with the formal change management process. Option B. Proceed with the VXLAN implementation without a formal change management process to expedite the deployment, as the business urgency outweighs the need for documentation and approval. Option C. Implement VXLAN in the production environment without prior validation of the control plane and data plane configurations, trusting that the new technology will function as expected. Option D. Deploy VXLAN across the entire production environment immediately to meet the business deadline, relying on vendor documentation for configuration guidance and assuming the technology is inherently secure. The correct answer is A. Implement VXLAN in a phased approach, starting with a small, non-critical segment, and conduct thorough validation of control plane and data plane configurations at each stage, integrated with the formal change management process. Explanation. Scenario analysis. This scenario presents a professional challenge rooted in the inherent tension between rapid deployment of new technologies and the imperative of maintaining robust security postures within a data center environment. The pressure to implement a new network segmentation strategy using VXLAN, driven by business demands for agility and isolation, conflicts with the need for thorough validation and adherence to established security protocols. The challenge lies in balancing these competing priorities without compromising the integrity or compliance of the data center operations. Careful judgment is required to ensure that the implementation, while swift, does not introduce vulnerabilities or violate existing security policies and regulatory requirements. Correct approach analysis. The correct approach emphasizes a phased implementation with rigorous testing and validation at each stage, integrated with a formal change management process. This aligns with best professional practices for network engineering and data center operation, particularly within regulated environments. The Cisco DCCOR curriculum stresses the importance of a structured approach to implementing complex technologies like VXLAN. This methodology ensures that security is not an afterthought but is woven into the deployment lifecycle. By performing pre-implementation validation, conducting staged rollouts with monitoring, and obtaining formal sign-off, the team demonstrates due diligence, minimizes risk, and ensures that the new segmentation strategy meets both functional and security objectives. This approach is ethically sound as it prioritizes the integrity and security of the data center infrastructure and the data it protects. It also implicitly adheres to general principles of operational security and risk management, which are often mandated by various regulatory frameworks that govern data center operations, even if not explicitly stated in the prompt's limited jurisdiction. Incorrect approaches analysis. Implementing VXLAN without prior validation of the control plane and data plane configurations is a significant regulatory and ethical failure. It bypasses critical security checks and introduces a high risk of misconfiguration, which could lead to unintended network access, data leakage, or denial of service conditions. This approach disregards the principle of least privilege and robust network segmentation, fundamental to data center security. Deploying VXLAN in a production environment without a formal change management process is another critical failure. Change management is a cornerstone of operational stability and security. It ensures that all changes are reviewed, approved, and documented, minimizing the risk of introducing errors or security vulnerabilities. Bypassing this process demonstrates a disregard for established protocols and increases the likelihood of unforeseen negative impacts on the data center's security and availability. Proceeding with the implementation solely based on vendor documentation without internal testing or validation is professionally negligent. While vendor documentation is a valuable resource, it does not account for the specific nuances of a particular network environment or the organization's unique security policies. Relying solely on it without internal verification exposes the data center to risks that could have been identified and mitigated through internal testing. This failure to perform due diligence can have severe regulatory and ethical consequences if a security incident occurs as a result. Professional reasoning. Professionals in data center operations must adopt a risk-based approach to technology implementation. This involves a systematic process of identifying potential risks, assessing their impact, and implementing controls to mitigate them. The decision-making framework should prioritize security and compliance throughout the entire lifecycle of any technology deployment. This includes thorough planning, rigorous testing, phased implementation, comprehensive monitoring, and adherence to established change management procedures. When faced with pressure to accelerate deployments, professionals must advocate for and maintain these essential controls, communicating the risks associated with shortcuts to stakeholders. The ultimate responsibility lies in ensuring the integrity, confidentiality, and availability of the data center infrastructure and the data it handles. Question 17. Analysis of a sudden and widespread network connectivity degradation impacting multiple critical applications within a Cisco data center environment. The initial investigation points to a recent, albeit minor, configuration change on a core distribution switch. The operations team is under immense pressure to restore full service immediately. What is the most professional and compliant approach to address this situation? Option A. Revert the entire network infrastructure to a known stable state from several days prior, without specific analysis of the recent change or its impact. Option B. Apply a series of broad, untested configuration modifications across multiple network segments to see which one resolves the connectivity issue. Option C. Proceed with making additional, uncoordinated configuration adjustments on other network devices in an attempt to bypass the perceived bottleneck and restore connectivity quickly. Option D. Immediately initiate a rollback of the recent configuration change on the affected distribution switch, followed by a thorough analysis of the rollback logs and the original change request to identify the root cause. The correct answer is D. Immediately initiate a rollback of the recent configuration change on the affected distribution switch, followed by a thorough analysis of the rollback logs and the original change request to identify the root cause. Explanation. The scenario presents a common challenge in data center operations, ensuring network resilience and availability while adhering to operational best practices and potentially regulatory compliance. The professional challenge lies in balancing the immediate need for service restoration with the long-term implications of network configuration changes, especially in a critical infrastructure environment. Careful judgment is required to avoid introducing new vulnerabilities or violating established operational procedures. The correct approach represents best professional practice because it prioritizes a systematic and documented method for troubleshooting and resolution. This involves isolating the issue, identifying the root cause, and implementing a solution that has been tested and validated. In a data center context, this often means following a change management process, which is crucial for maintaining stability and auditability. This aligns with general IT best practices, and depending on the specific data center's regulatory environment, e.g., if it handles sensitive data subject to regulations like HIPAA in the US or GDPR in the EU, though for this exam we focus solely on US frameworks, such processes are often mandated to ensure data integrity and security. The emphasis on documentation and rollback plans is paramount for compliance and disaster recovery. An incorrect approach that bypasses established procedures, such as immediately reverting to a previous configuration without proper analysis, risks masking the underlying problem or introducing new issues. This can lead to recurring outages and a lack of understanding of the system's behavior, which is a significant ethical and professional failing, demonstrates a lack of due diligence, and can have severe consequences for business operations and data integrity. Another incorrect approach, such as making undocumented configuration changes to fix the issue, is a direct violation of change management protocols. This creates an unmanageable network state, making future troubleshooting exponentially more difficult and increasing the risk of unintended consequences. From a regulatory standpoint, undocumented changes can lead to audit failures and penalties if the data center is subject to compliance requirements. It also represents a failure to uphold professional responsibility for maintaining a secure and stable environment. Finally, an approach that involves making broad, untested changes across multiple network segments without a clear understanding of the impact is highly unprofessional and risky. This demonstrates a lack of methodical troubleshooting and can lead to widespread service disruption. It shows a disregard for the interconnected nature of data center infrastructure and the potential for cascading failures. The professional decision-making process for similar situations should involve 1. Understanding the scope and impact of the issue. 2. Consulting existing documentation and runbooks. 3. Following a defined troubleshooting methodology, e.g., OSI model. 4. Engaging relevant teams and subject matter experts. 5. Adhering strictly to the change management process, including risk assessment and rollback planning. 6. Documenting all actions taken and their outcomes. 7. Communicating effectively with stakeholders throughout the process. Question 18. The assessment process reveals a critical security vulnerability has been identified in the Cisco Nexus core switches within the primary data center. The vulnerability, if exploited, could allow unauthorized access and potential disruption of critical business applications. The IT operations team is concerned about the potential for service interruption if a patch is applied during business hours, while the security team emphasizes the urgency of remediation. What is the most professional and effective approach to address this situation? Option A. Escalate the issue to senior management for a decision on whether to prioritize security patching over potential operational impact, without proposing a specific remediation strategy. Option B. Immediately deploy the security patch to all affected core switches during the next scheduled maintenance window, without prior lab testing, to minimize the window of exposure. Option C. Develop a detailed remediation plan that includes thorough testing of the patch in a lab environment, scheduling the deployment during a planned maintenance window with rollback procedures, and communicating the plan to all relevant stakeholders. Option D. Implement a temporary network segmentation workaround to isolate the vulnerable devices and defer patching until a less critical period, without a defined timeline for permanent remediation. The correct answer is C. Develop a detailed remediation plan that includes thorough testing of the patch in a lab environment, scheduling the deployment during a planned maintenance window with rollback procedures, and communicating the plan to all relevant stakeholders. Explanation. The assessment process reveals a critical juncture in managing a Cisco data center network, where a security vulnerability has been identified in a core network device. The challenge lies in balancing the immediate need for security remediation with the operational continuity of critical business services hosted within the data center. This scenario is professionally challenging because a hasty or ill-considered response could lead to significant service disruption, financial losses, and reputational damage, while inaction poses an unacceptable security risk. Careful judgment is required to select a remediation strategy that minimizes risk to both security and operations. The correct approach represents best professional practice because it prioritizes a structured, risk-assessed, and documented process for addressing the vulnerability. This involves thorough analysis of the vulnerability impact, evaluation of available patches or workarounds, and a meticulously planned deployment strategy that includes rollback procedures. This aligns with industry best practices for change management and incident response, ensuring that security measures are implemented effectively without compromising service availability. Adherence to established operational procedures and change control processes, which are implicitly part of a well-governed data center environment, is paramount. An incorrect approach that involves immediately applying a patch without prior testing or validation is professionally unacceptable. This bypasses essential quality assurance and risk assessment steps, potentially introducing new, unforeseen issues that could disrupt services more severely than the original vulnerability. This demonstrates a failure in due diligence and adherence to change management protocols, which are fundamental to maintaining a stable and secure operational environment. Another incorrect approach, such as ignoring the vulnerability due to perceived low risk or high operational impact of patching, is also professionally unacceptable. This constitutes negligence in security management. While operational impact is a valid consideration, it must be weighed against the potential consequences of a successful exploit, which could include data breaches, service outages, and regulatory noncompliance. A responsible professional must proactively manage security risks, not defer them indefinitely. Finally, an approach that involves implementing a workaround without a clear plan for permanent remediation is also problematic. While workarounds can provide temporary relief, they often introduce complexity and can become a technical debt. A professional approach requires a clear roadmap for addressing the root cause of the vulnerability, ensuring long-term security and stability. The professional decision-making process for similar situations should involve a clear incident response framework. This framework should include steps for identification and assessment of the threat, containment of the risk, eradication of the cause, and recovery of services. Crucially, it must incorporate a robust change management process that mandates risk assessment, testing, approval, scheduled deployment, and post-implementation verification for all changes, including security patches. Communication with stakeholders regarding the impact and remediation plan is also a vital component of professional practice. Question 19. Strategic planning requires a data center operator to evaluate the implementation of a new cloud-native orchestration platform designed to automate application deployments. Before proceeding with the integration, what is the most critical step to ensure compliance with data privacy regulations? Option A. Focus on integrating the platform with existing network infrastructure for seamless connectivity. Option B. Obtain immediate vendor certification for the orchestration platform, assuming it meets industry best practices. Option C. Prioritize the platform's performance metrics and scalability to ensure efficient service delivery to end users. Option D. Conduct a comprehensive data protection impact assessment (DPIA) to identify and mitigate potential risks to personal data arising from the platform's operation. Correct answer is D. Conduct a comprehensive data protection impact assessment (DPIA) to identify and mitigate potential risks to personal data arising from the platform's operation. Explanation. The scenario presents a common challenge in data center operations, balancing the need for rapid deployment of new services with the imperative to maintain regulatory compliance, specifically concerning data privacy and security. Professional challenge lies in navigating the inherent tension between business agility and the stringent requirements of data protection laws. A data center operator must ensure that all implemented technologies and operational procedures meet or exceed the standards set by relevant regulatory bodies. The correct approach prioritizes a thorough assessment of the new technology's impact on data handling practices against the backdrop of applicable regulations. This involves understanding how the technology processes, stores, and transmits sensitive data, and verifying that these operations align with legal obligations such as data minimization, purpose limitation, and security safeguards. This proactive, risk-based methodology represents best professional practice because it embeds compliance into the design and deployment phases, thereby minimizing the likelihood of future breaches or regulatory penalties. It demonstrates a commitment to responsible data stewardship, which is a core ethical and legal requirement. An incorrect approach that bypasses a comprehensive compliance review before deployment is professionally unacceptable. This failure constitutes a direct violation of regulatory frameworks that mandate due diligence in data processing activities. Specifically, it risks noncompliance with data protection principles, potentially leading to unauthorized data access, breaches, and significant legal repercussions, including fines and reputational damage. Another incorrect approach, focusing solely on the technical functionality without considering data privacy implications, ignores the legal and ethical responsibilities associated with handling data. This oversight can result in the inadvertent creation of compliance gaps, exposing the organization to regulatory scrutiny and sanctions. Professionals should adopt a decision-making framework that integrates regulatory compliance as a foundational element of any technology implementation. This involves 1. Identifying all applicable regulatory requirements relevant to the data being handled. 2. Conducting a thorough risk assessment to understand how the proposed technology might impact compliance. 3. Developing and implementing appropriate controls and safeguards to mitigate identified risks. 4. Documenting all compliance-related decisions and actions. 5. Establishing ongoing monitoring and auditing processes to ensure continued adherence to regulations. This systematic approach ensures that technical advancements are pursued responsibly and ethically. Question 20. Research into the implementation of new network virtualization technologies within a U.S.-based data center reveals potential conflicts with existing data privacy regulations. Which of the following approaches best ensures regulatory compliance while enabling technological advancement? Option A. Rely solely on the vendor's compliance certifications and documentation for the network virtualization solution, assuming it meets all necessary U.S. regulatory requirements without further independent verification. Option B. Implement the network virtualization technology with basic security measures and address specific regulatory compliance requirements only if they are explicitly flagged by a regulatory body or during a customer audit. Option C. Conduct a thorough risk assessment and compliance audit of the proposed network virtualization solution against relevant U.S. data protection laws, e.g., HIPAA, PCI DSS, state-specific privacy laws, before deployment, and integrate necessary compliance controls into the implementation plan. Option D. Proceed with the deployment of the network virtualization technology immediately to gain a competitive advantage and address any compliance issues that may arise after the system is operational. The correct answer is C. Conduct a thorough risk assessment and compliance audit of the proposed network virtualization solution against relevant U.S. data protection laws, e.g., HIPAA, PCI DSS, state-specific privacy laws, before deployment, and integrate necessary compliance controls into the implementation plan. Explanation. This scenario presents a common challenge in data center operations, balancing the need for rapid deployment of new services with the imperative to maintain regulatory compliance and data security. The professional challenge lies in navigating the potential conflict between business agility and the stringent requirements of data protection regulations, specifically those relevant to the U.S. jurisdiction, as implied by the DCCOR exam context. A data center operator must ensure that all implemented technologies and operational procedures adhere to applicable laws and industry best practices to avoid legal repercussions, reputational damage, and loss of customer trust. The correct approach emphasizes a proactive and integrated strategy for compliance. By embedding security and compliance considerations into the design and implementation phases of new data center technologies, organizations can mitigate risks effectively. This aligns with the principles of security by design and privacy by design, which are increasingly mandated or strongly recommended by U.S. regulatory frameworks such as HIPAA for healthcare data, PCI DSS for payment card data, and general data privacy principles. This approach ensures that compliance is not an afterthought but a foundational element, leading to more robust and sustainable data center operations. Incorrect approaches fail to adequately address the regulatory landscape. One incorrect approach might involve prioritizing speed over due diligence, leading to the deployment of technologies without a thorough assessment of their compliance implications. This could result in violations of data residency requirements, inadequate data encryption, or insufficient access controls, all of which carry significant penalties under U.S. law. Another incorrect approach might be to rely solely on vendor assurances without independent verification. While vendors provide documentation, the ultimate responsibility for compliance rests with the data center operator. Failure to conduct independent audits or validation can lead to overlooking critical vulnerabilities or non-compliance issues that could be exploited or discovered during regulatory audits. A third incorrect approach could be to implement compliance measures in a piecemeal fashion, addressing individual requirements as they arise rather than adopting a holistic framework. This often leads to inefficiencies, gaps in coverage, and a higher likelihood of overlooking interconnected regulatory obligations. The professional decision-making process should involve a risk-based approach. For implementing any new technology or service, a comprehensive assessment of its potential impact on data security and regulatory compliance should be conducted. This assessment should involve legal counsel, security experts, and relevant business stakeholders. The process should include identifying applicable regulations, evaluating the technology's features against these requirements, and developing mitigation strategies for any identified gaps. Continuous monitoring and periodic audits are also crucial to ensure ongoing compliance.